Hello, Miss James here. This is a quick screencast to review how do you solve problems when velocity and acceleration are involved. Let's first review the problem-solving steps. Remember, in order to get full credit, you're going to need to do all 5 of these, which is draw a diagram of the situation, make sure that you label that with numbers, and get a really good feel. You don't have to be a fantastic artist. A quick sketch will do. The second step is to make a table. This is an organizational trick to figure out what you're given and what you need to find. Next, you want to write down the formulas, then plug in the numbers, and then in the last part, give me the correct answer. And there are now two formulas we have to work with. One is average velocity equals the change in distance over time, and the acceleration is the change in velocity over time. That delta means change in, and it's the final minus the initial. Okay, let's try this model problem. In the 2008 Olympics, Jamaican sprinter Usain Bolt shocked the world as he ran the 100-meter dash in 9.69 seconds. Determine his average speed for the race. If you feel good about problem solving, pause the video here and try this problem yourself. If you are really flummoxed, let's talk about the answer, and I'll walk you through this one. Okay, so here's our problem. Our first step is to draw a diagram. Now, here I have a diagram. Notice that I've put in the numbers for what I know, and then I've also tried to highlight what it is I want to find. Okay, now the next step is to make a table of given and finds. I know the distance is 100 meters. I know the time is 9.69 seconds, so those go here, and I'm looking for the speed. Next step is to do the formula. Well, I need to relate distance, time, and speed. If I go back, which of the formulas apply? Distance, time, and speed? Oh, it's this one. So here we go. I've got the velocity equals the change in distance. Ooh, there should be a delta there. Over time. So the change in distance is 100 over 9.69, which is the time. Notice that I show which numbers I plugged in where, and then I get an answer. That's 10.32 meters per second, or an astounding 23 miles an hour. Why don't you try this one? In this one, this is going to be an independent practice. So pause the video here and try it. All right, let's see what we've got. Here you notice that we've got our diagram. The velocity of the puck starts at 9.32 and it stops at the end. And it's accelerating by minus 4.06 meters per second. And so we've organized that into a table. The 0 here stands for the start time or the initial time. Now in this one we have velocities, accelerations, and we're looking for time. So the correct formula to use is A equals delta V over T. When I plug in the numbers, I've got A is 4.06 minus the final, which is 0, minus the initial, which is 9.32 divided by T. Then I can cross multiply, so I take the T and bring it up here, and then I can divide both sides by 4.06, and I wind up with 2.3 seconds, so that's the answer. In summary, remember to use the 5 problem-solving steps, and if you want to, I would think that would be a good thing to put on your index card, and also the formulas that could possibly be used are V equals delta D over T and A equals delta V over T. Hope you found that helpful. Thanks.